Hello everyone, welcoming you to Shorup's classes. Today we are looking at the General Economics paper 1 of the IES 2022 paper and question number 11 and part A of the question. It is not possible to construct social preferences from individual preferences without violating one or more of the five axioms. Examine the statement given by arrow. Okay. So this is part A that we are talking about. So let us first talk about the five axioms that are there so that we can understand easily what we actually have to talk about and what is the social preference structure that is being mentioned in the question and how are we going to derive that from the individual preferences. So part A of the question. So let us first look at the conditions. Number one thing that is desirable for a social preference ordering is to follow non-dictatorship. So I hope most of you are aware of what exactly a dictator is. It is basically his preference is the one which is implemented as a social preference. No one else's preferences are taken into account while making the decision for the society. So arrow basically says that when you are trying to formulate a social preference from the individual preferences, it shouldn't be that only one person's preferences are replicated as the society's choices. That means there is no dictatorship type of preferences that are desirable. It is done so that everyone's preferences are taken account for, and then we try to see what best can be done for the society. I'm not writing it, but hopefully it makes more sense when I am telling that, because writing might make the things look a little bit more clumsy. Second is basically it should be unanimity. There should be a principle of unanimity. That means basically if all people in the society prefer something over the other, then it should be the social outcome. Okay, so I'll just try to write this down a little bit structured framework. So let's say capital N represents I'm just writing down as the next line. Capital N represents the set of individuals in the society. Okay, and let capital A denote the set of alternative choices that the society has to choose from. Okay, let Pi denote the so now I'm just writing it in a strict preference ordering over the alternatives. Okay, that means each individual has a particular preference ordering, right? And usually this is the notation that we take. Let script P of n denote the set of all possible preference profiles. Okay, I hope you understand what's a preference profile. You basically take all the preferences of the individuals and you have a profile of preferences. With that at hand, you need to decide what should be the social outcome. So it is a set of all possible preference profiles. And let capital P of n be a particular element from this set. Okay, fine. So that means, like, suppose we have something like this. So unanimity basically says that suppose there are two alternatives, A and B, small a and small b, small a comma b belonging to capital A, such that A is preferred by B for all I belonging to M. Then the social outcome should be such that the society as a whole prefers A to B, right? So if A is the top ranked alternative among all the alternate options that are there, then A will be implemented. So basically what unanimity says that if everyone prefers one alternative to the other, then we can easily say that the society as a whole prefers one alternative to the other. So this is the unanimity property that is desirable. Number three is known as um, independence from irrelevant alternatives. Independence from irrelevant alternatives, which in short is known as IIA. Now, what does it mean? Let me take an example without actually going in for actually writing that in a more formal way. For example, suppose you consider a election where there are three candidates. Election where there are three candidates. And let me name them as capital A, capital B, and capital C. So now obviously every agent of the society who has to vote will have some preference ordering over these three candidates. Someone he will prefer A the most, someone will prefer B the most, and likewise this will follow. Okay, so there is some preference ordering between all the three agents. And I am basically assuming over here that preferences are complete. That means all the alternatives are compared. Preferences are complete. Okay. Now let us, for example, hypothetically say that due to some reason, candidate C is not being able to take part in the elections. Then does that actually affect the preference ordering between A and B that the people of the society have? Technically, it shouldn't. And that is what we mean by independence of irrelevant alternatives. That means there is a particular set of alternatives. If you modify the set of alternatives, then it will not change the existing order between the alternatives. The alternatives that were already present, the ordering of those will remain unchanged. That will be unaltered. So I'll just write it down in a few sentences. If candidate C does not participate in the election, does not participate in the election, then this doesn't alter, then this doesn't alter the preference ordering over the other two candidates. Over the other two candidates. This is what it's meant by irrelevance, independence from irrelevance alternatives. Now coming to number 4, unrestricted domain. Now this might sound more like a technical point that is mentioned. Basically you mean that all preference profiles are taken accounted for. You are not putting any restriction on the structure of preferences. If it's becoming a little bit confusing for you to understand like what do I mean by putting restriction on preferences, think of something like this, which is known as the single picket preferences. Let me just write down two lines so that you can understand. There are no restrictions on the structure of preferences. All preferences can be accounted for. So now, let me write down example. Example of a restriction would be single picket preferences. Now, what does it mean? How it is differing over here? If I just draw a small graph to illustrate, you have something like this. So on the horizontal axis, you have all possible preference orderings. Now note one thing: the top rank preference, the so this is something like, let's say, your A star, the best alternative that you have, that is giving the highest possible satisfaction. One thing I can say, the farther away that you move from the optimal point, the lesser amount of satisfaction you will get, right? So let's say hypothetically I'm trying to compare these two alternatives, alternative A and alternative B. One thing that I can say for sure is that utility from A will be lesser than utility from B, because A is farther away from the optimal point, right? So I'm basically putting a kind of restriction on the structure that, look, these kind of additional properties the preferences will follow. That means we are saying that only there will be some particular preference orderings which are permissible. But over here, as far as Pareto is considered, we have an unrestricted domain. All possible preference orderings are possible. There is no restriction on the structure. Whatever structure is possible is fine. And finally, another important thing is that there can be often indifference kind of situations, right? You might be indifferent between two choices. So this gives us the fifth point over here, which is the social ordering. Okay. So what does it basically say? That each individual should be able to order choices in any way and indicate the ties, so that the social ordering can be done in a more organized manner. So let me just write down this line that I mentioned. Each individual should be able to order the choices in any way, should be able to order the choices in any way and indicate the ties. Okay. So these are the five axioms or conditions that Arrow says should be desirable in order to construct the, what you call it as, the social preferences from individual preferences. Okay. But interestingly, what he derives is actually, like many of you might be knowing, is something known as the Arrow's impossibility theorem, as he says, that you basically cannot derive a social preference ordering that satisfies all the five conditions. If you try to do that, one or many of them will be violated. Okay, that is what it means to say that you cannot basically construct social preferences by agreeing to, by encompassing all the five conditions that are mentioned. One or more than one of them will might be violated in that situation. So that is basically called as the Arrow's impossibility theorem. Okay, so we'll not obviously we are not expected to write a detailed proof of that theorem. That will consume way too much of time. But what we can do is basically illustrate that with a small example, and then we can conclude our observations. So let us come back to what I was talking about. Uh, the example that I just gave when I was exploring the irrelevance, independence of irrelevant alternatives, which is a election. Okay. So there is a election between three candidates. A, B, and C. All right. And just so that the example becomes easier, let's say that number of voters are some multiple of 3, maybe 30, something like that. Okay. And now let us consider a particular pattern of preference ordering of the society. Preference ordering of the society will be as follows if this is the situation. Let's say candidate A is preferred to candidate B is preferred to candidate C by 10 of the voters. This is the preference profile that they have. So by 10 voters, I mean one third people. Okay. So then comes ABC, BCA. This preference profile, this preference ordering is again by 10 other voters, which again constitute one third of the proportion of the society. And finally, it is CAB. Suppose this is the preference ordering, which is by the rest of the 10 voters, which basically constitutes another one third of the society. Okay. Now, observe one thing very closely. A is preferred to be in the first set and in the last set. That means the first 10 voters and the last 10 voters have a preference ordering of A is to B. So A is preferred to B by 2/3 of the society. Right? Similarly, B is preferred to C by the remaining by another 2/3. Check over here. In the first, you have this B preferred to C, and the second, you also have a B preferred to C. That means B is preferred to C by 2/3 of the society. Correct? Since all preferences are complete, every voter in the society is able to compare all the three alternatives. So preferences are complete and are basically transitive in that sense. So if you combine these two by transitivity, what should you get? A preferred to B, B preferred to C. So B is preferred to C, right? Sorry, A preferred to B, B preferred to C. So A is preferred to C. This is a straightforward result that you get. But this is not enough. If you look at the preference profile once again, you have two instances where C is preferred to A. Look over here in the second set of voters and in the third set of voters. C is preferred to A by 2/3 of the society, right? So what can you observe? By transitivity, you were getting by transitivity, you could say A is preferred to C by 2/3 of the society, and again over here also you can say that C is preferred to A exactly opposite 2/3 of the society. So this is the paradoxical result that we are obtaining. And this is essentially happening because we are trying to encompass all the 5 conditions that were there that are desirable for the social preference orderings to demonstrate. But the moment you try to encompass all of them, you end up with this kind of a paradoxical result, and you now don't know what the society actually wants. What is the social ordering? You basically now want to, for voting, what do we try to do? Out of the preferences of all the voters, we try to obtain a social preference. Which voter has got the maximum, and then followed by the other, right? So basically, what was happening by transitivity, what we could say that A is basically having the most number of preferences, right? Because has got the most highest social ordering. Then we could elect A. But again, if you look at the other part of the preference profiles, then we can say that C preferred to A is also a profile that we can see for the two-thirds of the society. Then what do we do? There's a contradiction. Either we can have A preferred to C and elect A, or C preferred to A and elect C. Then what does the social preference ordering do? So this is where the paradox is coming out in the arrows theorem. So that is what we were told to explore, that it is not possible to construct social preferences from individual preferences without violating one or more of the five axioms. And that is what we have tried to illustrate in the answer. Okay. Coming back to part B of the question, consider an economy with two goods and fixed factor supplies. Assume that the social welfare function is defined in the commodity space as this: W equals to x1 plus 2 times x2, and the society's implicit production function is x1 plus 2 x2 minus 1 equals to 0, and we are required to find the optimal values of x1 x2 to maximize social welfare. So this is something like a utility maximization problem only. So let us start with this part B. Our welfare function is x1 plus 2 times x2, and our production is basically x1 plus 2x2 is equals to 1. This is your welfare function. This is your production function, right? So the first thing that we should do primarily is that just try to check whether the welfare function is basically having convex indifference kind of curves. Then we can easily apply the Lagrangian to get hold of the answer. So in order to do that, what do? We differentiate that totally. dw is equals to partial derivative of w with respect to x1 into dx1 plus partial derivative of w with respect to x2 times dx2, right? So dw is equals to, this will be your x2 times dx1 plus x1 plus 2 times dx2. Okay, so for indifference curve, this is fixed, so this is 0. x2 times dx1 plus x1 plus 2 times dx2. So dx2 by dx1 is basically minus of x2 divided by x1 plus 2. So they are negatively sloped, the indifference curves or the isolevel curves. And the second thing that we need to check is for convexity. So differentiating double derivative with respect to x1. So that will be x2 remains, and this will be minus will be out, x1 plus 2 whole square, which is positive if x2 is positive. Now that is basically assumed. So basically the indifference curves are convex and we have a linear production function, and we can easily use the Lagrangian to get to the answer. Now there is a slight, I feel that there's an error in this question. I'll just show you why I'm saying this. You'll be able to understand. Now, the first thing that we need to do in order to find the maximization is to go for the Lagrangian. So we try to maximize the welfare x1 plus x2 times 2 with the restriction of the production function, holding with equality. So 1 minus x1 minus 2x2. Okay. So what do? We differentiate this with respect to the variables. Del pound del x1 is equals to 0. That gives us x2 minus lambda is equals to 0. Coming to the next one, del pound del x2 is equals to 0. So that gives us x1 plus 2 minus 2 lambda is equals to 0. And finally, with respect to the Lagrange multiplier, del pound del lambda equals to 0. And that gives us back the production function basically. So x1 plus 2x2 is equals to 1. Now look at this. What do you get from here? X2 is equals to lambda, right? And from here you get x1 plus 2 equals to 2 lambda. And what is lambda from the above equation? It is x2. So at the optimal, x1 plus 2 will be equals to 2x2. If I replace this over here, replacing um, this was 1, let's say this is 2 and this is 3. So I want to replace equation 2 and 3. So what do I get? In place of 2x2, I can write x1 plus 2 is equals to 1. And 2x1 plus 2 equals to 1. So 2x1 equals to minus 1. That means the optimal x star is coming out to be minus half, which is negative. Now this is what is a little bit perplexing out here. But if you obtain the x2 star from here, x2 star can be obtained by using equation 2 itself. So x2 star is basically x1 star plus 2 divided by 2, right? So that is minus half plus 2 divided by 2. So that is your 3 by 2 divided by 2, which is 3 by 4. And that is positive. And if you look at the welfare that we get by consuming this, just for you to be convinced, it is x1 star plus 2 times x2 star, right? So that is minus half plus 2 times 3 by 4. So that is 3 by 2 times 3 by 4, that is 9 by 8, which is greater than 1. Correct? Now this is a little bit shocking that we have your convex preferences, convex indifference curves, downward sloping, the standard assumptions are there in place, and we have applied the standard Lagrangian in that way. Then why are we getting a negative answer over here? Right? So negative quantities are not possible at optimal. So you might wonder that, okay, negative means that maybe the person will not consume anything. That means x1 star negative basically means that x1 star is equal to 0. Consuming negative quantity means essentially he's not consuming anything at all, right? That is what can be a plain structure understanding. So if you are not consuming anything at all, x1 star, then you will consume only x2. Then what will be the level of x2 that you will have from what is the production function or equation 3? So to say, it is x1 so x1 plus 2x2 is equals to 1, and at optimal it will hold with equality. So this is 0. So x2 star comes out to be half, right? So how did we go about this? X1 star is negative, which means that in optimal the equilibrium quantities can't be negative. That is not justified at all, and that means that probably he's not consuming and he doesn't want to, the society doesn't want to consume anything of x1. Which basically means that x2 star will be equals to half. So let me say double star rather, so that there is no confusion. Yeah. So what will be W double star? It will be x1 double star plus 2 times x2 double star. X1 double star is 0. So 2 times x2 double star, which is 2 into half, which is 1, which is lesser than W star. This is where the interesting observation is, that if you are forcing x1 star to become 0, you are earning lesser utility. So that is what the answer looks like. So this is a slightly perplexing issue with this question. Now, economically, if I can suggest that it should be the where there is some problem with the formulation of the welfare function, because for some of the people, some of you who might be aware, this is basically a kind of stone greery utility function that we call it. And the general structure is something like, in general, if you consider a two commodity utility, so that is x1 minus x1 bar to the power alpha, x2 minus x2 bar raised to the power beta, where what are x1 bar and x2 bar? It is the subsistence levels of consumption of these two quantities. That means if you are that is the minimum that is needed. Now over here it's plus 2, that means the subsistence level is minus 2. So that is why probably these kind of bizarre answers are coming out, but given the question at hand, this is what the answer should look like. This part is essentially optional, like you may do it, you may not do it, but just what I wanted to show you is that if you are trying to apply your economic intuition over here, that a quantity at optimal cannot be negative, then you're actually ending up with a lower welfare, which it basically tries to say that you are not basically optimizing to the best shot. Okay, thank you. So now let's move to the third part of the question, which is explain the compensation principle and the test criterion formulated by Hicks-Skitowski. Okay, so first let us get into the compensation principle. All right. So the basic idea is, whenever there is a policy that is implemented, there are some people who gain from the policy and there are some people who lose from the policy, right? They do not get as much as possible benefits from that policy, right? So every policy implementation that the government puts into action has basically two bifurcations minimum. One part which is the gainers and the other part are the losers from the policy. So now if you want to evaluate that has the social welfare improved as the implication of the policy, how do you do that? This is what the idea of compensation principle that tries to answer. Okay, so one part is basically losing, another part is basically gaining. Then how do you basically compare both the parts and try to say that whether overall the society has benefited or not? So if I can just put this idea in a short sentence over here, what we are trying to say in the compensation principle is that any policy implementation, any policy change has gainers in the society as well as losers. So now the question is, how can we then evaluate the change in social welfare due to the policy implementation? This is the fundamental question that we want to answer. So in order to do that, what the compensation principle tries to say is one part of the society has benefited and the other part has lost out on something. So what we try to do is that the gainers try to compensate the losers by giving some compensation payment. And even after giving that payment, if the gainers are actually better off than their initial condition, then we can actually say in the Pareto sense that the society has actually gained, because by giving the compensation you're bringing them to the level that the initial utility was, and after that also the people who have benefited are at a higher utility level. So that basically is the idea of compensation principle of evaluating the welfare implications of a policy implementation. So let me write down: any policy change. So the definition of compensation principle: any policy change that benefits one section of the society makes the other worse off. Right? Then, if the losers are given a compensation payment, a compensation payment to such an extent that the gainers are still better off after giving that, gainers are still better off, then this change leads to an increase in welfare. This is essentially the idea of compensation principle. Okay. Now, just let us take a very simple example. Suppose the society consists of two agents. Agent A has a utility of UA, which is a function of the levels of commodities consumed, and there is a agent B whose utility is UB, is a function of the consumption level of the different goods. So naturally, we can now draw a very simple utility possibility curve over here. Okay. So over here I have plotted UA, over here there is UB, this, and this is the utility possibility curve. Let us say that initially, without any new policy intervention, They are operating at a point, let's say like something like this, point A, inside the utility possibility frontier. So initially, so what does point A represent? The utility levels enjoyed by both the agents. Now suppose the government has a policy intervention. Now note one thing, that if you are moving in the northeast direction, uh, the diagram is not really neat, but I hope you are able to understand. Sorry, just a moment, let me just clear this out. Yeah. So if you are moving in this direction, let's say, not really good. Let me just redraw it once more. Yeah. So if you are moving in this direction of improvement due to the policy, then both the agents are improving, right? So let us say this extreme point is point B and this extreme point is point C. All right. This is what we can see, that if any policy implementation by the government leads to a direction, leads to a utility improvement anywhere in this region ABC, then both of them are having an increase in utility. This is for sure. But suppose due to implementation of any policy by the government, they are now resting at point D, somewhere over here, right? So what you can see from here, that agent B's utility has of course increased, but agent A's utility has actually decreased. So now how can we calculate the welfare implications? So let us say, let me just write it down initially with respect to the figure that I have drawn. Initially at point A, after policy implementation, we are at point D. And what do we observe? Utility of agent A at point D is lesser than utility of agent A than at point A, and but utility of agent B at point D is actually greater than point A. So this is agent A is worse off, but agent B is better off. So now the question is, how do we evaluate the welfare implications? How do we evaluate the welfare implications of this policy implementation? So what does the compensation principle tell? That the person who is better off will actually make a compensation to the person who is worse off. So how do you compensate? You try to give a compensation such that the worse off agent regains his initial amount of utility. Okay, that means basically, therefore, agent B compensates agent A such that, so what will happen? From point D, you will move to the right along the utility possibility curve and it will stop at point B, because the utility at point B is same as that of point A, right? So agent B will now compensate agent B, such that agent A regains his initial utility level. So he will come back to this level. Agent A regains his initial utility level. Correct? Fine. But after this compensation is made, we have now shifted from point D to point B. So now check what has happened. Initially, agent B was also over here, and now he's at point B. So definitely agent B has improved. So what is the ultimate conclusion at point B? Agent A is not worse off, but agent B is better off. Right? Therefore, social welfare has increased because at least somewhere in the society has higher welfare has increased. So this is how we work with the compensation principle. Now coming to the idea of test criteria that was implemented, that we have discussed over here. Test criteria. So this is essentially the reverse idea of the compensation principle. So let me just write down that first and then I'll explain what exactly is that. So it's basically reverse of the compensation principle. Okay? Because try to think of it in this way, that if the losers in the society know that implementing the policy will make them losers, then definitely they will try to stop that policy implementation, right? Correct. Then if that is the case, then obviously how do they stop it? They will try to go and the foremost thing is go for bribery, right? So the losers will try to stop the policy implementation if the losers from the policy change can't profitably bribe the gainers into making a change. Okay. Like obviously there will be a certain amount of bribe that will be demanded, but if the losers can't profitably, like after paying the bribe, they are not better off, then they will not be able to change the decision of the government. So this is the test criterion that is happening. So it is basically the reverse. In the compensation principle, what we are seeing, that after the policy has been implemented, then we are having the losers and the gainers, and then we are trying to account for a transfer of welfare so that we can compensate and look at the welfare implications. But in test criteria, what we are saying is that if the people who are going to lose already know a priori, then obviously they will try to stop that so that they are not being lost on the welfare after the policy implementation. So the best way that they can do is to go in for bribing the government officials. But if even after bribing they are not well off, then they will have no incentive to bribe, as a result of which they will not be able to reverse the idea of government implementing that policy. So just like in the example that I described over here, initially the society was in state A and finally we are at state B, right? So it's the reverse of compensation principle. So let me just write down two lines to understand this. The losers will try to stop the policy implementation. The policy implementation from B to A if the losers from this policy change can't profitably bribe the gainers into making a change. To making a change from B, A, from A to B, the reverse. So that is your answer to part C of this question.